Well, welcome everyone to this meeting of the virtual CICS user group. I'm sorry that we're slightly late starting. Can I just say that this is, in fact, meeting number 60, which means that as a user group, we've been going for 10 years, which I think is pretty good, don't you? Anyway, I'm Trevor Eddles. I'm CEO of iTech Limited. We're a mainframe consultancy, analysis and technical authoring organisation. We're responsible for the content on the Virtual CICS website, and we produce the newsletter. That website can be found at virtualcics.hostbridge.com. And we also look after the virtual IMS user group as well. So let's start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Eugene Hudders, President of CICS Corporation, and his presentation is called CICS Health Check. What does it entail? And a copy of the slides from this presentation will be on the website later today. And if you missed our previous meetings, you can download copies of those presentations from our website too. And you can also listen again to the whole presentation. There's a link on the resources page of the user group website. So virtualcics.hostbridge.com/resources.htm. So following Gene's presentation and any questions you have for him, we'll move on to the latest CICS news, latest CICS related articles. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting. And then I'll give you the dates and times for the next virtual meetings. So that's the plan for this meeting. And I'm anticipating that it will last for just over an hour. Anyway, as I just said, today's presentation is from Eugene Hudders. Gene is president of CICS Corporation, a company that developed CICS, a performance and problem determination tool for CICS. He's worked on IBM mainframe computers for over 50 years. He's made presentations related to CICS and VSAM at technical conferences such as Share, CMG, and WAV. And in addition, Gene's written several books on CICS and VSAM in the areas of problem determination and tuning, as well as many articles for technical magazines on the same topics. In his current position, Gene continues to develop new performance functions for CICS software and provides consulting and educational services for clients in the USA and Latin America. So, Gene, I'd like to thank you very much for being with us today. And what I'm going to do now is stop sharing my screen and let you share yours.
Okay, thank you very much, Trevor. Can you hear me?
Yes.
Okay, let me just get now, how do I get the share screen here? And okay, can you see the screen?
Yeah, that's gone full screen, so that's great. Thank you.
Okay, thank you very much. A good day to everyone. Sorry for the delay. I know that it's a little bit frustrating when you don't really know what's going on. But in either case, my name is Eugene Hudders, and I work for CICS Corporation. As Trevor mentioned, CICS is a product that we market that does problem determination analysis for CICS. Hold on a second here. See how I can now page up. Okay. The presentation, normally we have to do our normal disclaimers, and it's always nice to remember this product, CICS, and a bunch of them belong to IBM. And we always say that your mileage may vary because naturally every installation is different. Even though you're using the same product, CICS, there are things that make it completely different from one installation to the other. And you also have to remember that I'll be making a series of recommendations and so on. But sometimes management don't like to fix things, and they have the attitude that if it ain't broke, don't fix it. So some of this health check is basically trying to identify things that maybe today, are not such of a bother, or you don't really see anything with it. but management may not be readily to want to make any changes to your system for that. The agenda, I will basically talk a little bit about the health check, what the definition of it is and how it applies to CICS. We'll be doing an introduction. There's several things that are very important, but specifically, we want to try and make sure that we understand that tuning CICS and doing a health check of CICS is not just CICS as the address space. It also means that you also have to be looking at things like, for example, from a top-down approach, from the operating system all the way down into CICS. Then we will talk about some benefits that you have to have a periodic health check. We'll talk a little bit about where you can find some of this information. We'll talk about what traditionally we see as the health checks that are being done today. What are the considerations? And then we'll talk a little bit about some health checks that are not really taken into consideration today, and they should. Finally, we'll end up talking about the IBM Health Checker, which is a product that's there available to you. It's probably being used mainly by your ZOS system programmers rather than by the CICS. And we'll see it as sort of limited right now for CICS itself. And I hope that in about an hour we'll be finished. Okay. Now, what is a health check? If you look at the definition from the Oxford Dictionary, it says it's an examination to determine whether a person or animal is suffering from illness or injury. Okay, well, how does it apply that to CICS? Well, it's an examination of the entire address space and to determine how well your CICS system is running. You want to make sure that you're using effectively your resources, sort of the CPU, the virtual and real storage, and I/O. So if you look at what we're talking about a health check, it's really just an overall assessment of how your CICS system is performing. Today, most installations depend on some type of software products to help them with this health check. Specifically, they use performance monitors, things like OmegaMon, SysView, MainView, and TMON are the major ones that you'll see out there today. And those are the ones that are used to sort of check how the health of the system is doing. Now, one of the major issues that you have is the number of systems programmers that you have and the number of systems that you have to check. There are some installations that have few systems, less than 10, and there are some that have hundreds. So when you start looking at trying to do a health check, you require either a lot of people to be able to use these tools, or you have to have some type of tool that'll help you to go into that. One of the major problems, as I mentioned, is the lack of experienced systems programmers. As time goes by, more experienced systems programmers are retiring. And unfortunately, for some unknown reason, educational expenditures are limited in trying to train new people and to give them the background they need. And you can see that today when you look at the educational people that teach classes, that you'll see that they're, where they used to have 10 to 15 people attending, maybe 15, 20 years ago. Now, if they get 3 or 4, it's a real experience for them. So it really is a little bit of a problem when you start talking about trying to keep your CICS systems performing optimally, because again, most installations have relegated the part of performance tuning and problem determination to when the problem occurs. And you really don't want to do that. You really want to try and be proactive and find the situation, or be able to identify a potential problem in the future. And some things are just sort of buried there. In other words, they're there, and the proper conditions have not occurred for them to become a problem. And that's something that you want to try and identify with your health check of the CICS system. Now, there are 6 advantages that you have for doing a sort of a health check. One of them is like an operational cost. Outages cost money. And so you want to try as much as possible using this health check to help you keep your operational costs down. You also, if you have a good health check, You also be able to defer system upgrades. Now, that's not something IBM likes, but in long term, you want to maintain the mainframe. You don't want management to start looking at, let's start trying to go to open systems and eliminate the mainframe. So this is one of the things which is very important, is to make sure your CICS is running well, so that doesn't become an issue. You also want to try and be proactive. You want to be able to correct these things before they cause the outage. It's not a fun thing to have to go to your management to explain why you hadn't seen something come up and the system went down. You also want to provide stability. You want to make sure that during peak periods, your system can run and handle the situation. You also want to be able to spot abnormalities, okay, that affect, how your transaction rates go and how the utilization of your CPU, your IO, and your storage work. Finally, as a systems programmer, you want to be able to see the problem ahead of time so you can basically take action, okay? Now, as I mentioned, one of the most important things that you have to remember whenever you're going to be talking about CICS and doing a health check is that it really is a top-down sort of thing. In other words, it's not just fixing things within CICS. You have to be aware of things that surround CICS that are that contribute to CICS, its performance and so on. Things like, for example, your operating system, things like the workload manager, making sure you have the right priority and the right objectives that you have for WLM. How your TCP/IP and your VSAM are working, and security. Security can also take up some cycles if you set it up incorrectly. Okay, and things like, for instance, the inputs that you receive from CICS into CICS, such as MQ and TCP/IP, server and clients, and just plain 3270 type applications. And within CICS, and you have the applications themselves, and you have some things like how your COBOL and your PL1 or your Java are performing, and your temporary storage and transient data. And all of these come out, how your IO is working also for DB2 and VSAM and so on. So you can see them over on the right-hand side that, you can see the different types of IO that you need to be able to tune. And from a communications point of view, most CICS systems have some type of connection to other CICS systems, be it using IPIC or using things like MRO or ISC. So these are the sort of things that you need. And again, remember that all of these can affect how your CICS system can work. So you need, when you look about the health check of CICS, you're not only looking at CICS itself, you also have to look at the things that surround CICS, things that are on top of it, and things that are controlled by CICS as such. Now, where do you get some of this information? Well, most people, you have some type of product that will produce, make reports, batch type reports from your SMF data that's gathered every day. You also have the RMF monitor that you may have access. Some systems programmers in the CICS area do not have access to RMF, but if you can use it, it's a good product. Those third-party monitors I mentioned are also excellent products that help you, help you identify things and debug things and identify areas that need from a performance point of view. You have CICS has some internal transactions like the STAT and the CENT that will give you some information as to what's going on. IBM has now for several years had something called the ZOS Health Checker, and unfortunately, from a CICS point of view, it's not fully integrated. In other words, you'll see at the end that there are 3 things that it checks. And sometime in the future, maybe IBM will add some more. And as a user, you may want to add some on your own. Finally, you have the end of day statistics, which you can use to try and and identify situations. Again, all these are manual that you have to do them yourself. There are some third-party tools out there that can help you, also get some information for you from a performance and a problem determination point of view. And in some cases, some really weird cases, IBM may ask you for a dump, and that's when you really have a headache. And it's really a bad sort of thing to do, sort of thing. Now, from from a traditional point of view, what are things that you normally check? In other words, if you go into your installation, what do you look at? You may have, for example, you want to look at the overall CPU utilization and your CICS utilization. But specifically within the CPU, what are you looking at? You're looking at tasks that consume a lot of CPU time. And in particular, the ones that you want to look at are the ones that I call the fish tasks. And it comes from, there's three different types of inventory systems. One is the LIFO, last in, first out. You have the FIFO, the first in, first out. And then you have the fish. The fish is the first in, and they're still here. Those are the transactions you want to look at and see why they're still here. So this is the sort of thing that you need to look at. And some of the other things you look at are things like the CPU to dispatch ratio, which when you have a lot of the open TCBs and other types of TCBs, well, it becomes a little bit hard to understand when your QR is running well. You have things like max task, T-class limits that you monitor all the time, and you get messages when you start reaching max task. You also have things like, for example, how your DSAs are doing, be it below the line, above the line, or above the bar. And you look at things like how many times I've gone short on storage, how many times I've used the cushion, etc. Storage violations, fortunately, IBM across time, CICS, has managed to reduce the exposures that you have to storage violations. And so, you don't see them as much, but they're still there. Even if you use transaction isolation, you may still see storage violations. So, these are sort of things that affect the performance of your system, and storage violations in particular can affect it very negatively by bringing the whole system down. How your logger is doing, the overall paging and from the system and from CICS point of view. Things like example, weights on strings and buffers and NQs and so on. These are some of the things that you normally have. Your monitors may have some type of checks and send you messages, either beepers or they may send you calls and so on, or emails. Okay, so these are the sort of things that are most commonly monitored today. Okay, in general, if you go back and look at it, it's around 50, less than 50 conditions that you are today monitoring, and not necessarily in all the accounts that are looking at this presentation. And some of these things, they'll send you the message, and you really have to sit down and then analyze what the message really means and so on. So some examples of the traditional types of messages are things like, for example, wait on strings. And you have two types of wait on strings. From a VSAM point of view, is you have your wait on strings at the LSR pool level, or you have the wait on strings at the file level, either NSR or LSR. Okay. Other types of string waits from temporary storage or transient data. So these are things that you can get traditional messages saying you have this type of thing, or you may get an alert in your monitor that may say, you're getting a short on strings on this particular file or this particular DFH temp storage. Things, for example, things like example in storage. How's the percentage I'm using right now of my different dynamic storage areas, either above, below, or above the bar. Messages that you get that say, I'm approaching SOS or I'm at SOS. And new in CICS TS 5.6 is they now will send you a message when you're running sort of close in your OSCOR. That's the MBS storage that's available for you, either below or above the line. So they'll be measuring that, and they'll send you a message. Now that's new in CICS TS 5.6. In addition, those of you that are tuning in to share will also find that next week I will be giving a presentation on another feature that came out in CICS TS 5.6, which is the new mini trace associated with a task, which is designed to help you when you have a transaction that's a fish that's been there in a long time, and the odds of finding information within the trace of it regarding that particular task are long gone, because the internal trace is a wraparound. It probably already wrapped around and erased everything. So IBM has come up with a new type of trace trace, which is associated with each of the user tasks. In other words, the ones that you can specify in max tasks up to 2,000, and they'll be able to save them information. The bad part about it is you have to have the internal trace turned on in order to capture this information. But if you want more information, you can tune in to share next week, and I'll be giving that presentation. I think it's next Tuesday, in fact, in the afternoon. Other things that are, you watch are things like max tasks. It sends messages out when you're approaching max task or you're at max task. Either in the T class area, the same thing. The other things that come out, for example, in your monitors are, how are you doing with your CI and CA split activity within a certain period of time? Waits, the people that are waiting on exclusive control and so on. How many CIs you have allocated and used within temporary storage and transient data. These, again, are traditional type of things that you do. And some installations have gone, as I mentioned, gone a little bit further. Not only do they show it in the monitor itself, but they also can send you warning alerts. Things like you're reaching max task or you're close to SOS, this sort of thing. I'll give you a heads up so your CICS systems programmer can try to take some type of action and try to resolve the situation. Okay, now most monitors, as I mentioned, will present the information I said on the previous slide. The important part here is, being able to identify these resources that are used by CICS and how they're being misused and so on, or they're reaching some type of point. And it's important to get good information, when you got things like short on storage, wait on resources and strings and so on. So you can take action and try to fix them. Some of these things, unfortunately, will require a recycling of the CICS system, which is exactly what you want to avoid. And the reason why I keep saying that doing a periodic health check is very important, because it gives you the warning that you have a potential situation that will need attention. Now, some of the major considerations are things that are hidden. You don't see these sort of things. Your monitor will probably never tell you this, but here's an example of one. You start getting sort of the warnings that you're getting short on storage below the line. And you go out there and you start looking at the storage and everything else, and you see that maybe I can raise my DSA limb. Now, below the line, you may not be able to raise because you have a very limited amount of storage really available below the line. But if you can, you can go ahead and raise the thing, or you can sit down and find out what's causing this thing. And after you investigate, you find out that you're running below the line, that even though you have the programs are running above the line. When they compiled that program, they left the CBL card with the data 24 specified. Now, monitors don't normally look at this sort of thing. They look more from a general point of view for CICS. But this is something where all the data areas for the COBOL program, even though it's running above the line, is going to be having its data below the line. Okay. So the idea, as I mentioned, of the health check is trying to see things that are hidden, that you don't necessarily can see them from unless you go dig deeper into the definitions of the resources that you're looking at. The health check not only helps you from a tuning point of view, but it also helps you from a problem determination point of view of avoiding things in the future. You can also see, you use a health check to be proactive. In other words, you don't wait until the problem happens. You see it, you go in and you try to justify the changes and so on. Then again, the IBM monitor, this ZOS health check, and I'll talk a little bit more about this at the end, but it runs every half hour. And so you have something that's continuously checking the system. Now, your health checker, you have to determine how often you're going to run this. I mean, you don't want to run it every 1 minute, but you may not want to run it every 6 hours. So this is something that you need to look at and see, how many times you want to do it so that you can determine, because some problems occur and they go away. And you may not even know that it happened unless you look at some type of report at the end. So one of the things that you need to do also when you start looking at the health check is to try and grade these things. In other words, you have to sort of classify them. And we'll talk a little bit about those classifications. Okay, now, as I mentioned, in addition to those 50 traditional messages, we have been able to identify an additional 300. And every week, or every month, I find some additional ones to add. Things that, are really may never happen in installations, but you never know because I've seen them happen. Things, for example, somebody defines an LSR pool with 30 strings, but then if you look at the files in that pool, you find out that there's several files that have 60 strings defined for it. Now, from an LSR point of view, it doesn't take up any more storage and anything like that by having those 60 defined for the file. But the problem with that's the limit that you're setting for that particular file out of the total that you have available in the LSR pool. So if one day, for some reason, that file starts having some type of exclusive control problems where your task starts stacking up, you're not only going to affect that task that's accessing that file, but you're going to affect your LSR pool because that task can queue up to 60 people, 60 tasks before it, and it overshadowed the 30 that you had for the pool itself. So again, there are things that are, you have to look at. Now, unfortunately, as I mentioned, you just don't have, not that you don't have the capability, you just don't have the time to go into the in-depth of this. So as you start identifying these things, you start coding, having some type of code or something that will do it automatically for you, not only in one system, but in all the systems that you have. Okay. Any questions so far? You can put them in the chat, and Trevor will pass them on to me as soon as he can. Okay. Now, here's some additional things that that we look at. When you over allocate resources such as max task or T class, you're basically, in the case of max task, suppose you say I'm going to have 500 tasks. When you look at the peak, and the peak is 50. Okay, now the problem with that is fine, you're prepared for an emergency to get up to 500, but in the meantime, you're wasting a lot of WLM cycles because those, depending on how you set up your priorities on the workload manager, you could be spending a lot of CPU cycles checking these max tasks, these slots for max tasks that are created in performance blocks. So it's not only when you look at max task or T class, you want to make sure that you just not only are not reaching max task, but also that you're not over allocating max task. Things like that are very important. Things like, for example, you over allocate resources in VSAM files. Now, when you look at your monitor and your monitor gives you the information of your VSAM files, it'll tell you how much space you have. It gives you, for example, the high used RBA and the high allocated RBA. But you're going to have to sit down and see what, how much am I really using of this file that I have allocated. So these are things that you want to mechanize and be able to automatically identify those files that are over allocated. You also want to check if they're under allocated. In other words, you got a file that you loaded up and it's already gone into 20 extents because you didn't specify sufficient space when you did in the primary and your secondary. But also, you have to remember that if you take a CA split and you don't have any space, that CA split is going to cause having a lot of overhead, having to go out to the catalogs and getting the new space for the new secondary allocation for it. So these can affect you as such. You also have things like, for example, incorrect VSAM CI sizes. Now the data fine, but the index can cause you things like key compression problems, which basically mean that you're going to have a lot of unused space within the CAs. You want to also be able to get rid of unnecessary definitions. Things like, for example, transactions or resources that are disabled or resources that are never used. Again, that's something, that may be minor in a state, but it's cycles that you may be spending unnecessarily. Okay, things like, for example, I don't think any monitor checks to see if somebody has set up it with setting up the system dumps and the transaction dumps. There's an option there that says that if it occurs, shut down the CICS system. Now you can put it there and you can be running for years and it never happens, but somebody set it up and the day that it happens, the system goes down. And it's a heck of a way to go see your boss and explain to him that that was in there and you hadn't seen it. Things like, for example, on the DB2 side, you want to make sure that you have a good reuse ratio and a good look-aside hit ratio in your LSR pools. Okay. Now, as I mentioned, you want to classify, when you start doing this health check, you want to try and identify or classify the types of messages you're going to have. As I mentioned, you have over 300 of them. Some of them can be system informational messages, which is telling you how much CPU CICS is using, or how much, how your DSAs or what percentage are being used, and so on. Then you have some CICS informational messages, which are things like, for example, tell you if you're, if some of your SIT parameters are set correctly or incorrectly, and so on, or they could be better. You can have some warning messages, okay, that can identify things that are using resources. For example, a file that has 4 index levels instead of 3. When you look at that sort of thing, it's using 20% more CPU time, even if it's in memory, or it's going to be going out to disk additional to try and get those index levels themselves. And remember that, one of the biggest fallacies that you'll hear people say is, don't worry, we have a cache for the disk, so you don't have to wait for the IO. Yeah, but remember, you issue to get to the cache, you still have to cause an IO interrupt. I mean, on the thing, and you have to an SVC interrupt to start the operation. So you go through the operating system, the complete CPUs that are being used from an operating system point of view to get to that record. So, eliminating index levels is something which is very important. And finally, you have some potentially severe messages. Things like, for example, SOS and max task and so on, and poor look-aside hit ratios. Anything that has like physical activity to the IO, because that affects your response time. Okay. So these are some of the things, the classification. And you can add some, you can delete some, you can do whatever you want to, but this is more or less the general as we've seen them. When we divide them. And what are the major categories that you should address in a health check? Well, here's a whole list of them, and I'm pretty sure you have some additional ones you can add to this. We have CICS related things like SIT and resource definitions. You have NQs and VSAM data sets, that have to be looked at. You have things like data tables, LSR pools, and DB2 definitions. Definitions, which will help you, like, for example, the DB2 side to improve your reuse type percentage as such, and so on. So, I'm not going to go into every single one of these, but these are some of the things that you want to look at when you're looking at, what you're going to check from your health check for your system. And as I mentioned, right now, in addition to the traditional ones, there's about 300 of these that come out from the different parts on there, okay? And some of the examples of these are, for example, you want to check, for example, your ICVs, ICV, ICVR, and ICV TSD. Well, you want to make sure, for example, that they're set correctly, okay, for your particular CICS system. And something that nobody ever checks, at least I haven't seen it, is if somebody turned it off. In other words, your runaway task, you can set it to 0, and now you're not protected from people, falling into a loop. See, you've taken away the CICS capability to do it. Again, now, how many have that? You don't know. I don't know, because I don't think anybody really sits there and looks at 100 CICSs to see what the ICVR, if it's set to 0 or not. So that's the sort of thing you want to mechanize. That'll be done for you automatically. Things, for example, subtask equals 1 on a unit processor. IBM recommends that you don't do that. Things like having the device-dependent suffix turned on in your basic mapping support, the VMS file. You'll be surprised as to how many installations do not use the dynamic storage tuning parameter and the RUWA pool parameter for LE. And Again, the internal and auxiliary trace. And as I mentioned before, if you're going to use that, if you want to capture the KE trace, the mini trace I mentioned in CICS, you're going to have to turn on the internal one. And there are some parameters you can turn on to minimize, as far as the trace goes, some of the things that you want to trace that will reduce the overhead that you're paying for an internal trace being turned on. Another thing, as I already mentioned, is things like, for example, in your system the dumps and your transaction dumps, make sure that no one has put down the shutdown option on it. Okay. And again, these are things that may be there if it ever happens, and it never happens, so you don't know it's there. But you need something to be checking for it. That's all. Things like, for example, excessive use of the TCTUA and the TWA. We had a client that was getting short on storage below the line quite a bit. And, he was trying to see how he could do it. He had reached the maximum that he could basically define or expand his DSA as such. And you also have to be careful, because when you go to new releases or you install products that may use the LPA below the line, that can take away storage, a whole megabyte at one time from your below the line storage. So in this particular customer, they had 8,000 terminals defined with the TCTUA of 255 bytes. And the thing was, when you multiply that out, it comes out to a lot of meg, a lot of storage below the line that was being used. And he needed to reduce that. So he went through a cycle of the study, and he found out that the highest position he was using in a TCTUA was 45. So he changed the parameter on all the definitions of the terminals to 128, or in other words, about half. And he recovered a lot of storage, and he eliminated the problem of the short on storage below the line. So this is the sort of thing you want to do, including the TWA. A lot of people have the TWA still defined, even though they don't use it. When they went through the 20th century conversion, as I call it, we had to change that and make sure we had the full year. A lot of people took the TWA, what was defined in there, and moved it into their working storage. So it's no longer part of your linkage section as a 0-1 there. But unfortunately, that didn't eliminate the TWA, because you have to inform the systems programmer that he has to eliminate it from the transaction definition. So things like that, you want to check to see if somebody's using the TWA at all, to be able to get rid of those definitions today. Things like, for example, unnecessary load withhold. Again, what is this? Well, every time you issue a load withhold, you have a system LLE table that puts an entry into it, about 16, I think, if I recall correctly. And for example, we had a customer who used to recycle his CICSs every weekend. Eventually, they decided, no, we don't really need to recycle it. We're going to start holding it for a long time and recycle every 6 months, for example, or whenever you had some type of PTF that had to be applied. So what happened was they had 2 programs that ran every 15 seconds to check sort of the status of the system. And each one of these transactions that ran did 2 load withholds. Okay, well, every time you issue a load withhold, there's a 16-byte entry that's put into this LLE table. And as you can see, it's putting 64 bytes every 15 seconds. So when you start multiplying that out and take it out to 25, 26 days, they started getting short on storage conditions out in their CDSA sort of thing, because the person was doing that load withhold unnecessarily. They eliminated you only have to do it once, and that's it. But once they changed it, they eliminated the problem as such and got rid of it. And again, one of the things I mentioned is the unused resource definitions. Now, unused resource definitions is sort of, if you had to make a choice on priority, you probably want to do this last. Again, and it's the last sort of resort, because you know how many TXD may take, for example, maybe 300 or 400 bytes in the definition. You know how many you need of those to eliminate to get a 1 meg. So it's the sort of thing that you want to do at the very end, if you don't have anything else to do, sort of thing. But again, you'd be interested in knowing what things are not being used in the system. Okay, things like, for example, an LSR. Make sure that you're not using dynamic allocations because it takes slower to bring up the system. Plus the fact that it doesn't generate an index pool for you, a separate index pool from your data. So you're sharing the buffers between for both the data and the index. You have, if you get a particular poor look aside on a particular buffer size to try and improve it. Again, over allocation of strings and key length. I did a presentation a couple of years ago at Share. It's if you have access to the Share things, you'll be able to see it. But we did an example, or we did a test to see how much it took, how additional storage. A lot of people think it doesn't take a lot. Well, it does. We found out that you look at that presentation, when you put 255 for the key length and 255 for the strings, yeah, you're protected from the point of view that you won't get you won't have a problem with the key length, and you won't have, if you add a new file, and you'll also be protected that you're getting the maximum strings out there. But the problem is it takes hundreds of a lot of K of storage to do that. And that storage, and this is one of my own little recommendations is, I want the storage to be used for something which is productive, not just something that's out there and never be used. So, if I have an over allocation of strings and key length, then, what I want to do is try to recover that storage and give it to my buffers in my LSR pool. So I can reduce the amount of IO, physical IO that's being done. Things like, for example, buffer fragmentation. That's something that you don't really see very much, which is basically that you have a 10K buffer, 10K CI size, but you don't define either a 12K or a 16K buffer. So it's using a 20K buffer for the next highest buffer that's available. Okay, and things like, for example, no index pool defined. Again, that means that you're sharing those buffers between the data and the index. Things in the VSAM area, things like, for example, how allocate free space. You'll go out there and look, and you'll see many files that have free space specified, and they never receive an insert. So that's wasted space. Or you have the opposite. You have no free space specified, and you're getting a lot of inserts, and you're getting a lot of CA splits. So those are things that you need to look at and need to have in the health check to be able to identify those files that have those conditions. You have also people that have incorrect space allocations. Again, and when you look at extent processing, your file is completely locked out while it does that extent update. So it can affect your response times from other tasks that are waiting for some tasks that cost a CA split. Okay, and then again, you have excessive CI and CA splits, and you'll hear a lot of people talk to you about the fact that CI splits don't take a lot of time, but that's fine. But if that file is in LSR, think about the following: if I had a CI that had 100 records, right? And it basically occupied one buffer in the LSR pool. Okay, now if I get a CI split, I'll get one with 50 CI, 60 records, and another one 51. So that's 101 that you would have. But I need two buffers that basically have to accommodate the same thing that I did in one unbuffer. So that's something which is very important, and you also want to take a look at. Okay. Okay. Now, as I mentioned, this is sort of a top-down. Now, from a CICS point of view, this is not really your responsibility. That in fact, sometimes you can get in trouble with some of the systems programmers on the MVS side because you're going into their area and they don't like for you to be making, looking at things in their thing. But there are things that you should be aware of. For example, we already talked about the OSCOR. Okay, that's something which is an MVS type thing, but it's part of your CICS region. And you need to make sure that you have sufficient MVS storage to be able to increase, for example, your LSR pool sizes and so on. And so that's something that's very important. You also want to make sure that you're not close to, paging. If you're going to all of a sudden decide, okay, I'm going to change my TS, my temporary storage from being into disk on your DFH temp file. I want to have it all in memory because now it's above the bar. Okay, well, you better make sure that you have a good unreferenced interval count and a good available frame queue, which is the spare frames that you have available for, when somebody needs additional virtual storage, needs the frames, these real storage to back them up. You may also want some system informational from the MBS side. And so things like, for example, what my priority is from a workload manager. And that priority can be changing depending on how you set up your objectives. And also you want to know maybe how many transactions per second I'm handling, and get a good estimate as to how many transactions per second your region can handle. And there are things that you can do to more or less do an estimate on that. Okay, now to get a proper perspective of your health of your system, okay, you need to analyze not only the traditional areas, but these areas that are not covered by monitors, which I just mentioned a few. And as I mentioned, there's about 300 of those. And as I mentioned also a little bit earlier, every month we're finding additional ones to add. You want to be able to separate these things by category. You need to write them up, do them yourself or get a product that does it for you. And you want to make sure that you don't get, when you divide them into categories, you want to make sure that as you analyze the different CICS regions that you have, that you don't have one that has a lot of severe messages, because those are the ones that you need to attack immediately and try to get them going as soon as possible. The other problem that you have with the health check is there are some things that that you're going to identify, but they're not your responsibility. You can't touch it. For example, you can go ahead and play around with your LSR pools by increasing buffers, increasing strings and key length and so on. By the way, I forgot to mention when I mentioned the key length, one of the things that people worry a lot about is, what happens if I had to have a file and the key length that I have specified is too small? And if I try to add the file to that pool, it's not going to be able to open the file because the key length, the LSR key length is too small. Well, that's not really a big problem. What you should look at is, okay, if I have that problem, you have 255 pools available. So I'm going to take pool 251 and I'm going to dynamically open that file in 251. I'm going to assign 255 strings. Why 255 strings? Because it'll allocate additional, buffers for you, up to 255 for the data and the index, depending on how you have your percentage set up. There's a percentage when you define the LSR pool, which it defaults to 50%. So you would get at least 120 some odd buffers, but for the data and the index for that particular file. But you move it to that pool dynamically open it so that you don't have to worry about not having the key length, the correct key length. And as I mentioned, you have 255 LSR pools available today that you can use that. Okay, now the one last thing here is, how often should you run your health checker? That's something that's a decision, because again, when you're checking for 300 and some odd things, it's going to take a lot of CPU during that time. So you don't want to run it every second. First of all, it gives you all these messages and you're not going to be able to handle them. But at the same time, you don't want to do it every 10 hours or something like that. You want to do something like the IPM one, every 15 minutes or every 30 minutes, depending on how you want. So this is something that you need to determine when you health check. Okay, now that basically is more of the part. Let's talk a little bit now about the IBM Health Checker. It's a software package available from IBM, and it basically checks the configuration, the MBS side of the house. What it does for the CICS portion, which is supplied by Hersley, is really about 3 checks. And that doesn't mean that Hersley may not add more in the future. But at this point, there's only 3 that we've seen so far, and we'll talk about what those are. And they're mainly in the security area more than anything else. Okay, now, if you activate the IBM Health Checker within CICS, you will see a transaction called CHCK, which will run every 30 minutes. Okay, and it's there to report, how these three things that they put in there are working. Now, the health checker also runs, the IBM health checker also runs every 30 minutes. So within that scope, you'll be able to find out what has happened within those 30 minutes from a CICS point of view. Now, these three health checks, you can use these PIs here, PI 76965 and 76963 to get more information on them. And if you're in a backlog of ZOS 2.1 and 2.2, in other words, this is more 2.3 and above, you need those PTFs to get those in there. Again, once you activate it within CICS, you'll get that transaction CHCK, which runs at a priority of 254, and it's associated with the program DFHC Health Check program. And it will issue any messages for you, and we'll see what the messages you can get out, and you can see them on your console. The parameter that you need to activate this is the parameter called WLM Health. And that's, if you issue that, if that parameter is active, you will see this message, DFHHC 0101I, come out on your log. And it tells you that the CHCK is activated. And if you look at it, you'll see here, okay, this is the message that'll come out. That means that CICS is registered successfully with the ZOS Health Checker. And this is the console messages that are there. If you do a display, or in this case with IPCS, you take a look, you'll see that you'll find that the transaction is active and it runs on the QR TCB. Okay, it tells you it's not running and so on. It only runs every 30 minutes or so. And it's a system task. In other words, you won't see it with CEMP. Okay, you need to see the system tasks to be able to identify it. And if you go and look at the ICE that are in the system, you will see that this transaction CHCK will have an ICE there to run every 30 minutes. Here you see it, it starts, set it up at 11:07, and it will activate again at 11:37, okay? Now, that parameter is a parameter which IBM added several releases ago. And the idea behind it is to try and avoid a particular problem that happened with things like, for example, MQ. IBM would issue its message that said that CICS is ready for work, but MQ was not ready, was not completed. Its initialization was not complete. So with the WLM Health Service Check, what you see, and this is the parameter, what it looks like, okay? What it'll do is it'll delay for CICS to activate certain things, like, for example, things like MQ. And what it consists of two parameters that default to 20 and 25. The first one at 20 is the interval. Every 20 seconds is the default. And what it'll do is every 20 seconds, CICS will sort of activate itself and look and see if it has reached 100%. And how does it reach 100%? Well, it starts at 0, and every time it goes here, every 20, it'll add this amount and compare it to 100. So the first time it wakes up, it'll be at 0, it'll add 25 to it, and it'll be 25 seconds, 20 seconds have elapsed, and you're only at 25% of the way. After 4 intervals, it'll reach 100, and then it'll allow things like, for example, MQ to take over and so on. So you can play around with this, but most of the time you'll see just people taking the default. And it takes effect after the message that says control is being given to CICS. Okay? Now, one of the things that IBM has added, that Hershey has added to the health checker, there's 3 things, and here are 2 of them. One of them is called the CICS CETA access, and it involves, and I don't know why people would do this, but they do, that you have the SID parameter set to no, and you've left the default CICS user active. That means that anybody can access CETA using the default user as a sign-on, okay? The second one is the job spool, and checks to see if the spool is accessible to an authorized user. Again, you have to have the SID parameter spool equals yes, security equals no, and you've left Keki to be able to be accessible by the default user. So those are the 2 of them. The third one is similar. It has to do with the transient data internal reader. And again, it allows you to have CICS active because somebody put security equals no. And you have any TD transaction extra partition that says that you have the internal reader active. So these are the three messages, the three things that IBM is checking for today in the CICS region. There's a fourth one, which is not directly associated with CICS. It was there before. And that is, it checks to see if you've issued a QoS to an RLS type environment to the regions to QoS a particular file, and it's not responding. In other words, that region has not QoS and so on. And this is a sort of the message that you will get on the console for it. But this is also applies, this applies to your CICS system and such. Okay, now these are the messages you'll see. These are the things that says that you know see transaction available, the schools accessible, the TDQ and so on. The message that says that the CICS Health Checker cannot run because of an error. Again, and these are the three, you know, the other three messages you get on that available to an authorized user and so on. So anyway, this is the messages you can see on the console. If you see those, you know, you can go back and see why you have security equals no, which is probably the first question. Okay, so in closing, installations expanded the coverage of traditional health checks, and it has what we've seen is where they've gone in and done this sort of improved their health check in their system. They've been able to reduce their CPU and improvement in the overall CPU utilization. In many times, we've seen these particular clients to be able to defer having to make an upgrade to their system. They also have found that they've recovered wasted space. They've reduced the physical I/O, which is their response times. They've been able to recover virtual and real storage, okay, that can be used for I/O buffers, and it improved their response times also. And I mentioned you can defer the upgrades and so on. And you need to identify areas you need to analyze and code actions. Now, you can code for your ZOS health check. You can do the checking yourself, okay? But as I mentioned, you know, you have to code them yourself as such because Hersley has not done that for you. So thank you very much for your attention. If you have any questions, please, you know, put them in that. I don't know if Trevor, if you have anything on there.
No, not at the moment, but we'll give people a time to type something in.
Okay.
Just waiting. Doesn't look like we're getting anything. In that case, I will move on. If anyone does have any questions, then they can send them to me. My email address will be on screen in a few minutes, and I'll pass them on to Gene. Oh, here we are. We've got a thank you then from Tina Thomas. Says, thank you, great presentation. And then she asks, Trevor, where will the slides be available? Will they be available on the website later this evening, my time? So that's the virtualcics.hostbridge.com. If you go there, they'll be there. And there'll also be a link to the recording of this session as well. But it takes a little while for me to get hold of everything and upload it. Okay, well, I will move on, and let me say thank you very much then, Gene. That was brilliant, really in-depth, fantastic stuff. And as usual then, can you assume that we're giving you a virtual round of applause because we're a virtual user group? So thank you very much. Okay, yeah, Marcus Fitzberg says, great presentation. It's amazing to me how few customers actually read DFH. Stop. Right, let me share my screen then. Okay, right. In terms of news, too far. Right, Infotel then, they've announced version 2.0 of ECOX application parallel testing. or ECOX APT. This was designed to quickly spin up developer testing containers on the mainframe, built for Agile and DevOps methods. It accelerates application production on ZOS by running tests in parallel, allowing a team of developers their own sandbox to test and release iterations of their code. ECOX APT can find all the components of a CICS or IMS transaction with a click, and all programs and tables that the transaction uses are cloned in a test container. Mobile applications and internet development teams can create their test tracks of all the CICS or IMS transactions required and work completely independently of the mainframe developer team. And there's a link to that story on our website. As for articles and blobs, we've got which version of JKICS should I use? That's by Ben Cox in the CICS part of the IBM Z and Linux One community. And again, there's a link to that story on our website. Yeah, as always, can I ask for feedback about this meeting? Let us have any comments, anything you think might be better next time. And you can email your comments to me at trevor@iteched.com, or you can use the Contact Us webpage. As you can see, then planned for the future, our next meeting's on the 11th of May, when we have James Alexander, Director of Technical Services for Hostbridge, and he's going to be talking about building a CICS API live. And he says these APIs are ideal for making CICS applications available as callable web services. And then following that, the next meeting will be on the 13th of July, when we've got Colin Penfold, Technical Leader for IBM CICS Transaction Server Security. And he'll be talking on a topic to do with security. So just a quick reminder that you can keep up to date with what's happening in the world of CICS and on the Virtual CICS User Group website by following us on Facebook and Twitter, and by joining the Virtual CICS group on LinkedIn. The URLs are all on the homepage of the website, which, as I said, is virtualcics.hostbridge.com. Can I ask that you like us on Facebook? Everyone likes likes. And if you tweet or Instagram or anything, the hashtag to use is hashtag virtualcics. So that's all for this meeting of the Virtual CICS User Group. Can I thank you all for attending? Thanks to Hostbridge Technology for sponsoring our user group and making these meetings possible. And of course, I'd particularly like to thank Eugene Hudders for his presentation. So that's it. Thank you all very much for joining the meeting, and I look forward to seeing you again on the 11th of May. So thank you all, and goodbye.